Welcome to all our viewers. This is Camille with Astronomy News Network, and we've got an exciting story for you today. Back on July 11th of 2022, NASA revealed the first image taken by the James Webb Space Telescope. Now, the reason this image is so groundbreaking is because it revealed so many additional details which couldn't be captured by other telescopes, highlighting the potential the James Webb Space Telescope has to further help our understanding of space. Just to give our viewers an idea of just how much more detail the James Webb Space Telescope provides, here's two side-by-side images of the same region, the left one taken by the Hubble Space Telescope and the right one taken by the James Webb Space Telescope. Now, towards the center of this image, we see the galaxy cluster SMACS 0723, and due to this galaxy cluster's mass, it allows for the gravitational lensing of light from other galaxies, making said galaxies visible in the image. Now, if we zoom in, we can see one of these galaxies located 9 billion light-years away, dubbed as the Sparkler Galaxy due to the galaxy's nearby red and yellow dots. Now, just to be clear for our viewers, this is a single galaxy, but because of gravitational lensing, it appears in the image several times. So at this point, you might be asking, great, but what's so special about this galaxy? Well, those red and yellow dots that you see might be the furthest globular clusters we've been able to find, and studying them can help give astronomers insights into early galactic formation. Something that our viewers may find interesting is the magnification of the James Webb, along with the appearance of the galaxy several times due to gravitational lensing, helped astronomers to conclude that these clusters don't just happen to be in the James Webb's line of sight of the Sparkler Galaxy, but they in fact orbit the Sparkler Galaxy. The James Webb also allowed astronomers to map these globular clusters along the wavelength spectrum, allowing for a better understanding of their physical properties. Such technique was not possible prior to the usage of the James Webb, again just highlighting how important this telescope will be for future discoveries in space. Lamia Maula, Dunlap Fellow at Dunlap Institute for Astronomy and Astrophysics, along with her team, were able to confirm that at least 5 of the 12 objects are in fact globular clusters. She also hopes to utilize the James Webb to look at another 5 galaxies with observable globular clusters. If all goes well, this could effectively increase the data on distant globular clusters by 5-fold, which is very exciting. Something else Maula explained that our viewers may find interesting is the difficulty in determining the ages of globular clusters within the Milky Way compared to these globular clusters surrounding the Sparkler Galaxy. As the globular clusters in the Milky Way are very old, and the light emitted from them does not need to travel nearly as far, they appear quite old to us and are thus quite difficult to accurately age. Maula describes this as trying to determine if someone is 50 or 55 just from looking at a photo. On the other hand, the globular clusters surrounding the Sparkler Galaxy are very old, but it takes 9 billion years for the light emitted by them to reach the James Webb. Thus, we see the clusters as if they were 9 billion years younger than they currently are, and this makes aging them much easier. Maula describes this as trying to determine if someone is 1 or 6 years old from a photo, which is orders of magnitude easier than the previous example. We'd like to thank all our viewers for tuning in to this evening's segment of Astronomy News Network, and I hope you'll join us tomorrow for our segment on WASP 103b, the story of an exoplanet shaped like a lemon. You won't want to miss it.